Today we discuss about user interface design adaptation. It's a structure of presentation. Introduction. One of the main reason for increasing importance of adaptation is that we interact with our application in context of use, which are more and more varied because of the evidence of mobile technologies and smart environments. Various aspects can be part of the possible context of use and can be grouped along 4 dimensions. You can see these 4 dimensions. First of all is the user-related aspects, then technology-related aspects, then environment-related aspects, and finally is the social aspect. User interface, task, platforms, relations. In this section we discuss a logical framework that allows designers to think about the various possible relations between the task to perform the user interface and the platform available. We have identified 5 relations. You can see these 5 relations, and now we discuss about the second relations. Is the same task with different user interface on different platform. This is a desktop device which covers a wider spatial area and also provides an overview highlighting where the detailed view is located. The second is mobile device highlights the current position of mobile user, showing a smaller area with touch control to changing zoom level. Then, after multi-device interactive applications. Here, about supply environments. Supply's optimization algorithm finds the user interface, which minimizes the cost function while also satisfying all device constraints. You can see this supplies environment interface is a tool to make some applications. Then is Damask. First is the first approach to aftering multi-device user interfaces, which supports aftering for 3 types of platform: is a desktop, smartphone, and local. This desktop, smartphone, and local. Damask is based on 3 aspects. It's the first of all sketch, then layers and patterns. Sketches are used to identify easily what the user interface should look like. Layers indicate where the user interface part should be allocated to all devices or only to one specific platform. Patterns are used to identify solutions to recurring problems in order to facilitate the rows across different applications. Adaptation rule. This slide shows 3 pictures. First is a mobile device or a desktop device, and second is a mobile device. This rule name is splitting. Splitting the user interface into 2 or more separate presentations. You can see this Pac-Man game. In mobile, it's one single presentation, and in desktop, and in mobile, it's a version for small screens, in which there are 2 presentations: one for the playing the game and one for defining various settings. Second is replacement rules. Replacement rules. You can see figure. This show how a replacement rule can be applied to a group of elements instead of single elements. In this case, the grouping refers to query result concerning hotels. for a given location. Index of version shows the result group in such a way ways to provide additional information, and in mobile version shows the detail only on request touch elements that can be easily selected by touch. Adaptation rule. We have the adaptation rules can be expressed in the format event, condition, actions. So first of all, it's event. The user has selected the link, a printed description. For example, condition. The user has selected more than 3 links to printed description, and action shows the 5 most sold printers. Next slide is a model-based UI design in multi-device context. In model-based approaches, the basic idea is to use language that describes the main aspect in conceptual term in order to allow designers and developers to concentrate the main semantic aspect and avoid having to learn a plethora of implementation language. The community working of model-based approach has agreed in identifying a number of abstraction levels that can be considered when describing interactive application. First is the task and domain objects. Task and domain objects is a level. The purpose is describe the activities that should be performed in order to reach the user goals, and the objects that need to be manipulated for this purpose. Second is the abstract interactive applications. At this level, we focus moves to the interactive part of an application and aims to provide its description in term independent of the interaction modality used. Then concretive interactive applications. The description is modality dependent but independent for the implementation language. And the last one is interactive application implementation. Here we have the actual implementation in some implementation language. These figures show a small example of multi-device user interface obtained through a model approach. Maria authoring environment. It provides a graphical direct manipulation support to edit interactive application at various abstraction levels and generate the corresponding implementation for various platforms, also using different interaction modalities. These figures show how the tool supports editing a logical description. Technical for the adaptation phase. Exists three adaptation the main phases is the first of all device identification, then interaction resource identification, and adaptation. First is the device identification can be performed as a server or client side. In the server side case, usually the user agent detection in the HTTP protocol is carried out. For example, here we have some examples. It's a normally indicates system and browser information, platform details, extension. For example, Mozilla derivative 5.0, iPad, something else. Interaction resource identification is applied when it's necessary to have more detailed information on the current available interaction resource. And the last one is adaptation. Adaptation is have three phases. In the first of all is the scaling, transducing, and transforming. If you want, you must some read just linear scaling according to the interaction reserved to available device, such as a Safari on phone, and does not loading a web page developed for desktop system. Then it's a vocal vocal interface. Recently, there have been increasing interest in vocal interface since vocal technology is improving. This we show we have some feature which it shows corresponding vocal menu automatically derived according to the to an algorithm in which the texts of the vocal menu items are derived either from elements ID or from the section contents. In the this part you have you see a vocal dialog that can be obtained from such vocal interfaces. Then multimodal user interfaces. In this figure we can see the general architecture for supporting adaptive multimodal user interfaces. The context manager able to detect events related to the user, technology, environment, and social aspect. Then the adaptation engine receives the description of the user interface and the possible adaptation rule. The description of the user interface can be obtained through the authoring environment at design time or generated automatically through the reverse engineering tools at runtime. When events associated with any adaptation rule occur, then the corresponding action part should be executed. For this purpose, three options are possible. First of all, it's a complete change of direction modality. Then some change in the current user interface structure should be performed. Then a small change in the current user interface should be performed. Change of some attributes in some elements. Distributed user interfaces. What's distributed user interfaces? Distributed user interfaces and migratory user interfaces are two independent concepts. Indeed, there may exist distributed user interfaces which are also able to migrate, but are also only distributed user interfaces. Or migratory user interfaces are not distributed across multiple devices. Multi-device support is emerging in various environments. You can see, for example, distributed. What does it mean? For example, is a mobile version. We distributed some dynamic tools. We to distribute in mobile way for desktop device, and it's some example. For example, we have one presentation page, and we have some other distribution presentation page. In mobile desktop device, only two presentation in one. It's the architecture of this, how to distribute it. So this migratory interactive application. I show some YouTube video. So
it's common for a user to have multiple personal devices today, but it's painful to migrate a task from one device to another. Here Bob just looked up directions on his desktop computer, but how would he easily open up the same map on his phone for navigation in his car? With Deep Shot, Bob moves the interactive map to his phone by simply taking a picture of it using a mobile camera. Deep Shot captures not only shallow pixels, but also the information behind the scene, that is, the work state of an application. So
It's
here the
really
captured
cool,
map
yes.
remains interactive on the phone. In
It's
addition
really
to
cool.
pulling out information, Deep Shot also allows a user to push
It's
information back
vice
to a
versa in
computer
mobile
using
phone
a
to
mobile phone
computer.
camera. Let's say Bob just had a great dinner at a restaurant and he wanted to put in a good word for the restaurant.
What, for example?
He opened the page for writing a review, but it is a pain to type on a mobile phone. So how would he move the review page to a desktop computer where he can easily type? Again, use Deep Shot. Bob aims the camera at the computer screen with the review page still open on the phone. Deep Shot identifies the intended computer by matching the screen image as seen through the camera, then the page opens on the target computer automatically.
It's really good, yes. So, in conclusion, I want to say, to summarize, we can say that a variety of solutions have been developed to better exploit multi-device environments. It can be useful to have a set of logical dimensions that allow designers and developers to compare them. A set of such dimensions with some values, it can be useful to identify to differentiate them. It provides first of all is distribution, migration, teacher activation type, interaction modalities, timing, adaptation approach, architecture. Of course, we are still far from having solved all these the interesting issues that characterize multi-device environments. There are various aspects that deserve further investigation, such as integrated support for adaptation to variety of post-WIMP interaction techniques, or more general solution for preserving the functionality state in migration. So it's all. Thank you for attention.